Hey everybody, this is Larry. This is day 20 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. So I do solve and explain these problems live. The cool thing maybe is that I go through my thought process and not just the solution. So, feel free to fast forward or watch it on a higher speed if you want to go straight to a solution or watch another video. It's fine. Anyway, so today's problem is decoded string at index. So, okay. What is it? What does that mean? Okay, so basically, whenever you see a number, you repeat everything that's the prefix of that number of times, and then you have to find the kth index of that string. Okay, that sounds reasonable. Okay, and okay, so for one digit, it's just one, so we don't have to worry about like parsing a 22 is just 2 twice. Okay. Just d minus one more time. Okay. So okay, well, I guess from here we can clearly see that it does not make sense to generate the string because we repeat this a lot. Okay. Wow. To be honest, I was just reading the problem. My first inclination is just to generate the string in some way, and looking at the constraint, it doesn't seem like, obviously you can't really generate the string from scratch, and then even k is big, so you can't really do anything that's capped on k on a constraint. So you have to really think about how to do this. And how would I do this? I mean, I think when it comes to this problem, the way to do it is probably going to be some kind of what I call bookkeeping, or keeping track of certain variables in a way that allows you to keep going. For example, every time you see a number, maybe you could either use a stack or some kind of implementation to kind of figure out within that how many things to take care of, right? And I think that's actually not that bad, but in terms of algorithm, I feel like I could figure it out. The implementation is always also going to be tricky, so this is probably tricky on both parts. So let's do it together. But yeah, I think my idea is that, okay, you either have a stack or some kind of data structure that allow you to go from left to right, and then every time you see a digit, the current length, and as soon as we reach k, we know that we don't have to parse the end of the string. But then now the question is, how do you combine these strings, right? I mean, I know that here we can combine these two, just multiply them, and that's fine, that's easy. But if you have something like, actually even this one, how do you combine them in a good, effective way? Is it just counting? Because here you know that there's four characters up to the 2. Now you know that there's 8 characters, 9, 10, 11, 12, and then times 3, so that's going to be 36 characters. I don't know if there's 36 characters, but that's the way to kind of go. Is that good enough? Not gonna lie, this is a tricky problem for me because there are a lot of potential for off by ones as well. So I'm thinking about how to cleanly implement it, even though I have a general idea. Okay, I mean, let's play around some concepts as we go, and then we'll see. So yeah, let's play with that. I think there's going to be some combination of scanning from left to right and also recursion. I think it'll be okay. I don't think this is that bad, but it's just have to be really careful. So we're going to start with an empty string, and then for x in s, so for each character in the string, if x is in if x is a number, then we have to do the thing. And obviously in Python this is actually very simple, but we are trying to not generate the string because that would be disastrous, right? So okay, so a string is not going to be enough. Let me just create a list, and then we'll parse out the list, and then we could figure out what the situation is. Okay, so yeah, okay. I'm just trying to figure out how to name this as well. Let's just go current. I am terrible with naming right now. So yeah, so current dot append int of, or just x. Otherwise, if it is a string, then what I want to write is something like take the last string and then we add that to x to kind of add the current string going on, but that is not going to be quite correct if the last string is empty, or or it's just a number, right? So okay, so if length of current is equal to 0, or the last element is an int, then we set this to a new string. Otherwise we just append it to the last one. Okay, so let's make sure that our thing inputs or outputs what we expect to do. So let's give it a quick go. That is actually what I want, so that's good. Let me also, while I'm at it, put in the other two test cases. What is the number that they want? 5, and then some ridiculous number. Okay, so the length of the number, I think 1, but same thing. Yeah, and I think so the ongoing length of the string is actually not that hard, because okay, so current length, say, is equal to 0. If it is number, we take current length and then we multiply it by that number. Otherwise we just increment by 1. I think this should be good enough to get, so this is the final length of the generated string, I believe. So we're gonna print it out. So why do I print so much stuff out? It is just for visualization, and this is way too long. So let's see. But it has this big number that is the same as this number, so I think so anyway. So that should be good. And the second one also, let's see, what did I say? Yeah, 36 and 8. So that's good. Because I think I said 36 earlier, and this is clearly 8. So okay. So at least we know this recurrence is true. So then the question is, how do we get the kth element, right? And this is going to be going backwards, I think. So, how do I want to do it? So the current has the thing. I think almost we want to terminate early so that we can care about it now. So, okay. So if current length is greater than k, it may be greater or equal to, we may have to do it off by ones, but I just want to get the general idea right. If this is the case, then we only care about, and then we don't do the operation that is now, right? It's a little bit yucky. That's why I'm thinking about the best way to do it. Because this is already, that means that this is already too big, but that's fine. Okay, so then that means that we only care about, then current will have the number that we need. And then now, we, or the answer is in current. And then now I have to think about how to construct this, right? So basically the idea that I would have is that we have some function, f of x, say, and then we want to convert this based off the transformation that we're doing here with respect to either times 2 times something or increment by 1, and then map it to the new thing, right? So okay, so we start with k. Maybe that's another way of doing it. It's just we keep track of k, right? So So if we add, so this, we should be able to go k minus 1 because every new character that we see, we decrease k by 1, right? And then here, what does this mean, right? Well, this means k subtracted or equal to in sub x, or maybe beforehand, right? Because basically, like if you go from 2 times 2 to 4, you actually want to get the delta, which is 2. So this is just equal to the current length times this minus 1, right? That's kind of the idea, but we're going to go over because this, we're going to check by 2 later, and this is going to be negative, right? So basically, we want to add an if statement, which is also, okay. If k minus 1 is equal to 0, then we return the current string. This is so annoying. Okay. So then here we, in theory, this is the last string. Actually, no, this one is easier because then this is the last string we append, which is x, maybe. Okay. Let's just return, oops. If k is less than or, yeah. Because if this is true, then that means that the string is within the new thing that we expand. So now we want, let's just return error just so that we kind of test this case real quick. Okay, so this works for these two. Of course, that's not meant to be exhaustive, and I know that this is not the case intentionally. And yeah, we have used the same amount, but let's just say 2. This should give us the wrong answer. And if we have and then we do 3, that should maybe give us the right answer. Decoded string is, yeah. I mean, this is not that interesting to me, so that should be okay. Yeah. So now our behavior is expected, and then now we just have to be careful about this, right? And that means, what does this mean? This means that within the current length, like whatever we're repeating, it is within that, right? And that period is going to be, what is that period? That period is just the current length before you get multiplied. So then now, if this is the case, then we want how do you say this in a good way? Basically, it's just current length mod k, I want to say. Is that true? Because basically you have something that's repeating, and then you want to get the kth amount. So it is the k mod the current length would be the new k. Right? Okay. Yeah. Okay. So we do this mod current length because this is the multiply. And again, there might be an off by 1 here. I have to double check this for a second. Because this is also 1 index, which is always a little bit weird to be honest. But yeah, maybe this messes me up. So let me make this 0 index. Yeah, and let me unsolved. Oops, I know I mistyped it, but it doesn't matter. So let me make sure that this still gives me what I expected to give, and then now let's give this answer k. Okay, so then now we know that this is within the thing, so we have to return an answer here at some point. And then now we could back out exactly from the current, right? So then now let's look through the array. Okay. And I think, to be honest, you could probably have, I think I did it this way, but you can actually just have the current, the parsed string at the end, and then just go to the back. And maybe we'll do some refactoring to that. I think maybe I like that better, maybe, I don't know. This case is easier to handle here like this, but this case is a little bit shaky with respect to that. But yeah, so now we want to go. Okay, so now this is before, right? So let's do while current is greater than 0, and so then now we check the last character. If the last string is numeric, and maybe this is where concatenating them is a little bit silly. Maybe I should just do them one by one instead of concatenating the string. I thought it might be easier, but I actually don't think. Yeah, I think this doesn't change anything. So let's actually just always always create a new element. And here, yeah, that's good. So then now we can just check whether it is numeric directly. If it's numeric, then what happens, right? Well, if it's numeric, again, that means that it repeats. And it repeats at the frequency that is the number that we get here. So, okay, let's just say last is equal to the int of current minus 1. So this is the last number, and it repeated last number of times. So that means that per port will be current length to the last, let's just say period. And then k, we want to mod that by period. Okay, and then we pop, because now we have to go further to get the string, right? And then else we just subtract by 1, because can this be 0? I guess so, but we only can solve this here in the string portion, because we don't have the string otherwise. I think maybe. Let's check. If k is equal to 0, we return current of -1. Else k minus 1, and also current.pop. Okay, this is actually really terrible code, I think. I mean, the logic, you saw how I did this progressively, logic by logic, but it is tricky for sure. Okay, so there is some weird issue here. Why do I get a mistake here? Oh, I see. Because we append before we do the multiplication. So actually the first thing that we should do is well, we don't have to do anything. Let's just move this until the end. Okay, then this may turn out a little bit better. Okay, I mean, it's not right, but at least it's fun, right? And I just don't know if this is off by 1 as well. I mean, all the other answers are right, so it's very possible that this is off by 1. Yeah, if this is 0, no, it is not that it is off by 1. It is that I see. Okay, I think actually it's not that it's off by 1. It's that I'm counting backwards. So if this k is equal to 0, I need to get the entire string and not just the last character. Okay, so what I was doing earlier made sense again, which is that if length of current is equal to 0, or the last one is numeric. That's why I was doing it that way, but I forgot. Or I don't know. This is tough, so hope you appreciate it. Okay, so then now if this is the case, then what do I do? If this is a string, okay. Let's think about this, right? That wasn't even right. Okay. So if this is a string, so if it's a number and it's in, then we do this mod thing, which is fine. If not, if this is a string, what does that mean? That means that it could either be part of the string or it cannot be, right? So I think that's So we have to think about it as well. For example, if you have something like ha2, something like that, say, if your input k is like, I don't know, 6, then it's actually let's just go. Let's use another one. Ha2 and I don't know, low, high, low. So then this would actually be high, high, and then low, and then high, high, low, right? So then if you go 6, this will be in the second part, but 5 would be in the first part, 4 would be the first part, and so forth. And we divide it by 2, so or we mod it by 6. So this is actually going to give us the 0 that we want. But then now this part doesn't tell us anything because it's not going to be in this part, right? So what does that mean? That means, okay, I have to think about it a little bit, but I think I got it, which is if, so the length of the current of my the last string that we're looking at, so this is going to be the last characters. So this is like the end of the string, the suffix of the string, right? So suffix is equal to this, say, oh, this is the suffix, but suffix length is this length. If current length, so this is the current length minus suffix length, or let's think about the other way, maybe. Let's see, right? So basically the suffix length minus that, it's going to be, so the prefix length, okay, let's write it that way. That's easier to read, I think. Prefix length is equal to this, right? Because together they create an entire string. So if k is less than, again, I have to think about the thing. Then that means that if this is in the prefix, then we have to keep going, right? So current.pop, we don't even have to change k because we know that it's going to be inside the prefix, so that's fine. Otherwise, k minus equal to prefix length, and then we can just return current, the last string, and then the k element. Okay, is that clear? I don't even know if that's clear. I mean, again, I might have an off by 1 anyway. But, oh, answer's not defined. Where'd I have answer? I forget. Oh, here. No, I don't need it. Okay, well, it was worth a shot. No, I mean, I think it's still right, but I think there's some off by 1 somewhere. Is this, if k is 0 indexed, I think this is right, but or like roughly right. Okay, let's check here. Prefix length, suffix length, and then k, right? So what do we expect to see from here without, well, we expect to see a little bit more, but let's just do sk so I could see which test cases this is working for. Okay, so ha2 or ha22, so it's s. What is s? Oh, s is just the input. Why is s like this? Did I overload it by accident? Oh no, s is the first one. Okay, so it's k. Okay, we get the, is that right? We want to get the 4th character, right? And that's gonna be h. So 1, 0, 1, 2, 3, 4. I guess that's right. Okay. Prefix length is 2. Suffix length is 2. Is that true? Current length is 4. I think I'm off by something here. So we have 4. With 2, we times 2. I think this is equal to, I think that's why. Okay, So okay, so there is an off by 1 and we did fix it, but I'm not confident about this at all, right? This is a struggle. So let's test more cases. So here 20, 30, 32, 33, 34, I don't know. I'm very not confident about this, so I am going to put as much as possible, and there you go. I am rewarded for my testing a little bit. But beyond that, I am going to take a quick look to see the other answers to see if they're right. Because if they're wrong, that means there are other things as well. No means a couple of things, so we'll definitely figure out what that means. Why do you even have no? Or like, how is it possible to have no? On top, we only return in one place, so that makes it easier to debug. Just for cleaner debug, let's print out everything here. Bottom, say, I don't know. And here, top. Because no is already when, I mean, no can probably only come up when I have an off by 1. So that is good in a way. So top is, I thought I put 2 now. So top returns A. C and O, there's no top at all. So what happens? What happens, I guess, is actually, this is just returning impossible maybe. Because I thought that maybe it's returning no here somewhere, but it may be just that, okay, all the loops are running out. That is odd though. Let's also, okay. I mean, this is very odd, but that's why we're debugging. Well, this is a very long problem, but yeah. Okay, so K is hugely negative, so something definitely went wrong somewhere. Oh, well, there is some assumption about this loop invariant where I mean, this cannot make this negative, right? So it has to be here, and therefore, I mean, the only subtraction is maybe here. I mean, and this is not possible to be negative, right? Because of this statement. So that's how I would check about the invariance. The only thing that is tricky is here. So let's add an assertion here. And see if that's where it fails. Yep, that's where it fails. But how is this true? Okay, I guess, so let's also add a impossible 2. So I think it's just doing the is possible 2, but then it goes through. So then that means that there's something with this loop invariant that is a little bit off. Because my invariant here is that we will go to K is equal to 0 at some point. And this would, be sorted out. But apparently not. Oh. Did I get this right? If this is in the prefix, okay. Let's if K is in the prefix. So okay, let's see. Let's just add something like a prefix check. That we can remove these 2 for now. Maybe I'll need them later and I'll regret printing them out, but now we know where the bug is, and hopefully this debugging is valuable for you as well. But okay, and in cases of K is less than prefix, we pop. Yeah, okay. Impossible to, how does that work? That means, this is so weird. No. Okay, let's actually also add current -1 on the top string to see. I'm having trouble visualizing what's going on. So, okay, so why is there an extra space? Oh, because okay, that's intentional. Or, well, not intentional, but it is what the code that I wrote. Okay, so first, so prefix check, the last chunk, 3K, right? Actually, let's add the print impossible so we have a delimiter. Okay, so here it is 1, the prefix is 4. Did I did this well? The prefix length, so this is the suffix length, right? If, why, I think my signs are just wrong. If K is, no, because if K is bigger than the prefix length, then this happens, right? So we have this, then yeah, then we know that this is in the current string. Otherwise, we pop the last string, right? But we have to, we have to minus some K here, and I think we haven't done that. That's probably why. We want to, so then K, no, we don't, because we can ignore it. That's my original logic. We're going to ignore it because K is already smaller than the prefix length, so it's going to be in the prefix, which is the rest of the current, right? So then we can get rid of this one. Okay, but then why? Tell me why. Let's run it real quick. Okay, so this, it claims is impossible. S is less than, oh sorry, K is less than prefix length. So this should pop, but it's already on in the beginning, right? Why is this prefix length 8? Did I do something weird here? Oh no! Oh, we don't update current length in this because I just forgot. I am not a smart person. Okay, so period is this. When we pop this, actually current length shrink by last. I don't know how I forgot about doing this. And then here when we pop current length minus the length of the suffix. So yeah, okay. So wow, how did that even pass so many test cases? Not, you know, maybe it's just a little bit lucky. Okay, so this looks a lot better. So yeah, just silliness. Let's give it a submit. I am still not that confident, but let's you know, got my fingers crossed. But I did get a lot of test cases right. So so this seems like an off by 1 because it's just AAB and I return A and B, which is unfortunate. But like I said, I got a lot of things right. So so there's an off by 1 somewhere here that we were worried about for sure. Where can it be though? Is it this one? Was that was the one that I wasn't sure about. Because if this is greater than, you can remove it, right? So if they're the same, okay, that's the one that I had doubts on earlier. That's why I pinpointed. Okay, that's actually lucky because I think I should have tested a little bit more. So this is a mess of a code. I have a long explanation as you were here for 35 minutes. Apologies for that. But let's have a recap. Recap is just being really careful of the problem. I think you have, you just have to keep track of a lot of things. There's nothing, I don't think it's complex to figure out the formula of, okay, when you have a number, the current length extends by this much, and when you have a string or a character, the current length extends by this much, by 1 in this case. And it's just about being really careful, which I wasn't enough. And yeah, I mean, I think other than this minor thing, I think most of my code worked the first time, and also this thing. Though I had it right initially, but and then I don't know what happened. But cool. So what is the complexity of this? Well, for each character in S, we push it into the stack. This is actually a stack, in case you're wondering, even though we didn't call it that. You push it onto the stack once and you pop it off the stack once. So that's going to be linear time. In terms of space, again, because we have a stack and each character can be pushed on the stack once, it's going to be linear space. So that's all I have for this problem. It is very tricky, but to get right correctly, well, I guess you can get right incorrectly, but it is very tricky. So definitely just be careful, take your time, and let me know what you think about this problem. And I will see y'all tomorrow. Bye-bye.